All right, hello again and welcome back. This is Jeff Scott of Rankin Technical College. And we are starting to go through our textbook for the AWD1100 Programming Fundamentals with C# class. All right, the book is Microsoft Visual Studio, Microsoft Visual C# 2017 and Introduction to Object-Oriented Programming by Joyce Farrell. All right. So, notice our objectives. This is a very general chapter. We want to describe the programming process, be able to differentiate between procedural and object-oriented programming, describe some of the features of object-oriented programming languages, describe the C# programming language, which is object-oriented, write a C# program that produces output, select identifiers to use within programs, improve programs by adding comments and by using the system namespace, and finally compile and execute a C# program using the command prompt in Visual Studio. Alright, so again, much of the stuff that's in this chapter is very general, for lack of better words, even sometimes boring in nature. Alright. So, this is a programming class. The previous class that you took, the AWD1000 Web Technologies class, that was a class in web design. This is a class in computer programming, and in particular in programming using the C# programming language. So, they define here a computer program as a set of instructions that tell the computer what it should do. And really, that's a pretty good definition. There are two basic types of programming languages. All right, and those two types of programming languages are system software and application software. System software is more concerned with operating systems and things like that, and application software is what we're going to be doing. As it says, it allows users to complete tasks. Now, this is totally a software class as opposed to hardware. The hardware is the computer itself and all the physical devices that are associated with it. The mouse, the keyboard, the central processing unit, printer, etc. What we want to do is we want to write high-level language, C# code, that we run through a compiler, and that compiler will convert our C# code into machine language. Machine language are the series of ones and zeros that the computer can understand. Ones are typically thought of as being on or true, where zeros are typically thought of as being off or false. Again, as I mentioned to you previously, C# is a high-level programming language. It'll use very English-like words. All right? It'll allow you to assign reasonable names to areas of computer memory. Those names usually are going to be what are referred to as variables. C#, like any other programming language, has its own syntax. It is a case-sensitive language. Typically, at the end of most lines, you'll need to put a semicolon, and you have to use what are called reserved or keywords in their right context. All right? Then, after you've written your C# program, you attempt to do what's called compile your C# program. When you compile the program, you're attempting, as it says there, to translate your high-level English-like language statements into the machine language zeros and ones that the computer can understand. If the computer cannot understand what you're trying to do, it flags each error message. And each time it finds an error, and there'll be three different types of errors, but if it finds an error, for instance, if you were supposed to put a semicolon at the end of a line and you didn't, it'll flag that as what's called a syntax error. And that's an error when you use the language incorrectly. When you think back to the day, whenever it was, 3rd grade, 4th grade, it doesn't matter, when you wrote your first essay, all right, your teacher might have said this has to be 1 page long and it has to be 3 paragraphs. Well, you probably either put a blank line between each paragraph, or you indented the beginning of each paragraph, and you made sure that at the end of each sentence you put a period. Those are syntax rules of the English language. You started each new sentence with a capital letter, that kind of thing. All right? And programs themselves, computer programs, have their own type of syntax. So the C# language, like any other language, has got to be used in a certain way. And if it's not used in that way, you'll get error messages. All right, that's one kind of error you can get. Another kind of error is the syntax is okay, but you did something that's considered to be illegal. Maybe you tried to call some kind of a routine that you have not written yet. Maybe you tried to divide by 0. Those are what are referred to as runtime errors. So the computer doesn't catch those until the program's running. The last type of error is a logic error, and that the computer can't catch. As an example, if you mean to add two numbers, but instead you subtract one from another, the computer doesn't know that you meant to add them. All right, so that would be an example of a logic error. The last thing I want to mention before I leave this slide is they talk here about a compiler. All right, and I want to differentiate between a compiler and what's called a translator. All right, some languages run through a translator and then compile, or a compiler and then translate. Okay, but what we're doing is we're using a compiler. So imagine that what I'm doing is I meet somebody on the street and they want to ask me directions, and they're from another country. And they speak Spanish and I speak English. All right, but I'm very, very, very good with directions. And they start to ask me how to get someplace. And I want to explain it to them, but I'm not really sure what they're asking, and they don't understand what I am trying to tell them. So another person walks by who's a translator, who knows how to translate from English to Spanish or Spanish to English. So what happens is, all right, so what happens here is I sit there and let's have them go first. They sit there and they tell me exactly what they're looking to do. All right, and they give me a whole bunch of directions. And the person who is going to do the translating has got a pad of paper with them. And every time they say something that the translator doesn't exactly understand, they write down that on a piece of paper. All right, so now they're done. And before the translator can actually do the translation, she or he has to ask that person, what did you mean by this? What did you mean by this? And eventually, hopefully, they understand everything. And then they ask me that in English. And then the whole thing goes in the other direction. With a compiler that we're using, the computer runs the entire program regardless of, or attempts to go through the entire program regardless of how many errors there are, and it flags each error. Then when it's done, it'll show each error to you. I'll have plenty of chance to show you this as we go on in here. With a translator, the program has to stop every time it finds an error. You have to fix it, then it goes on and it stops when it finds the next error. Okay? So we're working with a compiler. We are going to attempt to use program logic, and that'll involve using the various statements and procedures that are available in the language in the correct order and in the correct way in order to produce the results that we want. All right? The chance of most people of writing any kind of program, and this includes me, writing any kind of program that is at all has any degree of complexity to it without making any mistakes is very minimal. When you have a mistake in a computer program, each mistake is known as a bug. The process of removing all the bugs from a program is known as debugging. Now, as it says there, you can use debugging to remove your syntax and your logic errors. You don't remove your runtime errors through debugging. All right, debugging means that you are sitting down, maybe getting a hard copy, a printed copy of your code and going through it line by line. Syntax errors, as it says, are discovered through compilation. Logic errors are discovered through testing. Really, so are runtime errors. You're running the program. Now, up until, I don't know, the first few years at least of computer programs, and the way many computer programs still are, is they are procedural in nature. With procedural programs, you use variables, all right? You write a series of steps to manipulate those variables, okay? And you break your code up into logical units that you and the computer can understand, typically called either methods or functions. And those methods, functions, sometimes even called procedures, they're called or invoked by different parts of the program at various times. All right, a single procedural program often has hundreds of variables and thousands of method calls. I spent the first few years of my programmatic career working for AT&T Bell Laboratories, and I was working on what was called 5ESS. That's version 5 of the electronic switching system, and the code that I worked with was approximately, I think, somewhere around 5 million lines. Now, did I work on all those? Of course not. I was responsible for somewhere in the area of, I don't know, maybe 10,000 or so lines. In addition, when we created new features, I was responsible for some of the work with those new features. Now, more and more programs today are object-oriented in nature. In fact, object-oriented programming, or OOP, as it's known, is an extension, so it builds upon procedural programming. Object-oriented programming is not new. The first object-oriented programming language was Simula 65, SIMULA 65. Called that because it was a simulation language that was developed in 1965. That means it's about 53 years old. All right? With object-oriented programming, you work with objects and classes. A class is a blueprint, just like a blueprint for a house. An object is an instance of a class. Just like when you create a house based off of a blueprint, it's a house object. So objects are similar to objects in the real world. I just gave you an example. Each object has their own attributes. So if I made a person object, their attributes might be height, weight, gender, etc. And it has their own behaviors. All right? Behaviors are also known as methods. For instance, we all eat, we all drink, we all sleep, but we eat different things, we drink different things, we sleep different amounts of time. The attributes of an object are also known as its characteristics. The behaviors of an object are also known as its methods. So the attributes are its characteristics, the behaviors are what it does. Putting that together, you get what's called the state of an object. All right? Here's an example. So if I was working with a paycheck object, that paycheck object would have three different, these things that you see right here, these are attributes. It would have somebody who's going to get paid, the number of hours they worked, and the gross pay. It could have a lot of other things, but that's what we're assuming right now. We calculate what that amount is, we write the check, and eventually they'll cash the check. Notice that these have parens afterwards, otherwise they look pretty much like these. The parens afterwards, which can, but don't have to have anything inside of them, that means these are methods. Without the parens, it means they're attributes. So as mentioned here, an object-oriented approach to programming means that you define objects, yet it's even higher up than that. First, you create classes, which are blueprints for objects, just like a blueprint for a house is a blueprint for a house. Then you define the objects based off of that class. These objects are whatever objects you need to accomplish whatever tasks you're trying to create. Originally, as mentioned, object-oriented programming used two different types of apps: computer simulations, I already mentioned Simula 65 to you, and graphical user interfaces, or GUIs. For a language to be considered object-oriented, it must, at a minimum, support, it doesn't mean you use all of these, but it must support at least these 5 concepts. Classes, and I already told you that a class is a blueprint or a category, all right, that you're going to use to create an object or objects. All right? The class describes what the attributes are that the objects have and what the behaviors are for each object. Then you create objects. Each object, again, is an instance of a class. Each object, when you create an instance, it's known as instantiating or in class instantiation. Each object has its own set of attribute values, also known as properties. You also have encapsulation, and encapsulation is also known as using a black box type of mentality. Now, if I were to get out of here and I was to go and do a control P, the system would expect I wanted to print these slides. And if I click print here, which I'm not going to do, it would print those slides. I don't know what magically happens from the time I click print until the time those slides come out printed as on paper in the printer. I don't have to know because it's been encapsulated from me. It's hidden from me. It's a black box mentality. I don't know what happens to make that happen, and I don't have to know. So I can use other classes that people have used, or that other people have created, or that Microsoft has created, that has their own objects, that has their own attributes, that has their own methods, and as long as I know how to use it, I don't have to know inherently what it does. And if you're still confused, look at it like this. If I come in here, and I bring up the calculator, and I type in 367, and I hit the square root key, I have no idea internally how the computer gave me that answer. I have no idea whatsoever. And I don't care. It really and truly does not matter to me. All right? All that I care about is that when I typed in the number and hit that key, that it gave me my answer. This right here is known as my interface. What happens to make this number turn into that number, that's called the implementation. So I see the interface, but the implementation is hidden from me. So if someone decides that they come up with a new way to generate square roots that's much better than the way we're doing it. Maybe now when I do this, when I click 367 and I hit this, maybe when I do this, even though it was instantaneous, maybe it's taking 7/100ths of a second. And somebody came up with a brand new way of doing this where it does it in 1/100th of a second. So it's doing it, basically 7 times faster. Well, if that can be put into the implementation of the machine that I can't see and my interface stays the same, I'm none the wiser for it. So what I'm telling you is if Microsoft creates something and I'm using its interface, but its implementation changes, I don't have to know about it as long as the interface doesn't change. So the interface, as it says, is the interaction between a method and it's the object's exposed behaviors. We use what's called a message passing system to do request and receive information. All right? Object-oriented programming languages also have inheritance. Now, inheritance is kind of like genetic inheritance. Typically, if you've got, and again, I want to sound politically correct here, but typically, let's suppose that you have a man with a big nose who gets married to a woman with a big nose, and they have a baby. There's probably at least a good chance that baby getting the genes from both parents or inheriting from both parents will have a big nose. So the kid grows up, has a big nose, and doesn't like it. When you think about it, there's really probably 2 things that they can do. They can have surgery to have it replaced, or they can live with it. It's not like they can take the nose off and replace it with another nose. But that is what you can do with object-oriented programming inheritance. So if you inherit something from a parent and you don't like it, you can go and create your own. So inheritance, as it says there, provides the ability to extend a class to create a more specific class. So if I created a class called bank account, I could use inheritance to create a more specific class called checking account and another class called savings account. And both checking account and savings account would inherit from bank account. Then there's polymorphism. And imagine that I had 3 pets. Let's say I've got a dog, I've got a cat, and I've got a bird. And I teach each one of them to talk. All right? So my dog is Rocky, my cat is Kitty, and my bird is Sparky. So I say, Rocky, speak. And since he's a dog, he goes, roof. I say to the bird, Sparky, speak, and it tweets. I say to the cat, Kitty, speak, and it meows. Each one of those is responding to a speak command or a speak method in the way that's appropriate for them, the way they know how to do anything. And that's polymorphism pretty much in object-oriented programming too. As it says here, it describes the ability to create methods that act appropriately depending on context. So the programs can distinguish between methods with the same name based on context. All right, now let's talk a little about the C# language in particular. C# was developed as an object-oriented programming language. As mentioned there, it's part of the Microsoft Visual Studio line. We'll talk about that, but just not today. C# allows every piece of data to be treated as an object and to use object-oriented programming features. C# features a GUI or graphical user interface. It's modeled after C++, but it's not the same. It's similar to Java. In fact, I have called C# Microsoft's answer to Java. It says their C# is more truly object-oriented. You can draw your own conclusions after you've learned both languages. When we want to start to write ourselves a C# program that produces output, we'll be using, among other things, literal strings. And a literal string is something that appears inside of double quotes. So we will do things that look more or less like this. We will say something along the lines of, stretch this out a bit, string first name equals Jeff. Int age equals 61. Boolean, I don't remember if it's bool or boolean, but we'll see, is married equal true. All right. Salary equals, let's put something down that I don't make. Let's put 250,000. All right. These are an example of 4 different kinds of C# variables. A string, which is a literal set of characters, which must be within double quotes. All right. An age, which is a whole number, so it's of type int. A Boolean, which is a true-false value. And salary, which is, when you think about it, let's say that I make that and 83 cents. All right, so I can't say salary equals, I'll say something like double salary. So there's an example with string, int, Boolean, and double. All right, let's talk about even one more. How about this? Char, mi for middle initial, equals P. My middle name is Paul. All right, you're going to see all these, and I might not have even been totally syntactically correct on all of them. I just did a Java lecture, so the syntax between those two languages is not identical. So if I goofed up a little, sorry about that. Whoops. All right. We will end up calling methods. Those methods may have arguments. If you don't understand what that means, look at it like this. Let's assume that my daughter comes home from school. All my kids are too old to be in school, but and I tell them, I call this clean the room. So they get home and I say, clean the room. All right, and my daughters, at least at times during their lives, have been wiseacres, and they'll say something like, oh, whatever, Dad, what room? So if I say clean the room, let's say they really messed up, upstairs, bathroom. Well, this is what's called an argument. I've got a routine that I'm going to write called clean the room, but we need more information. We need to know what room. So we provide that. So this is the name of the method. Then inside of the parentheses, I've got the argument. There can be more than one argument. Maybe I have to tell them what they need to in order to clean that. So they need a toilet brush. They need I don't know, some kind of soft scrub. And they need paper towels. So clean the room is the name of the method. Upstairs bathroom, toilet brush, soft scrub, and paper towels would be examples of arguments. So methods are not the same as variables because methods have parentheses. The parentheses can be blank or empty. I could also, maybe I want to call clean the room. And what if I live in a one-bedroom a no-bedroom apartment. I live in a studio where everything is in one room. Then I might be able to just say that, clean the room, which means clean everything. All right, so it can be very simple and very complex. All right, WriteLine is an example of a C# method. WriteLine is a built-in C# method that allows you to display output on the screen. There is a write and a write line. When you use WriteLine, you display something on the screen and it's like you hit enter to go down to the next line. With write, you display it on the screen and your cursor stays at the end of that line. So here's our first example of looking at some code. And I don't expect this rather to make a whole boatload of sense to you. When you write C# code, you write what's called a class. We already mentioned that. So the name of the class is first class. Every C# program that we create, all right, let's just say by and large every one that we create, especially ones that are not graphical, which is what this one is not, will have what's called a main method. And main is our point of entry. It's where the program begins to execute. And this says, I want to write on the screen, this is my first C# program. And the system isn't smart enough to know, well, where does WriteLine live? WriteLine is part of what's called the console package, which is part of the system package. So I need to say system.console.WriteLine unless I put something special at the top of my program. We'll look at that in a bit. All right. To make this a little easier for us to use, we're going to add a namespace up here. So we're going to say something like above this, and it has to go above our code. We have to say something like using system.console, exactly how it looks here. System.console with a big S and a big C, then a semicolon at the end. If I put that there, then instead of having to say system.console.WriteLine with this, all I have to say is WriteLine. That's what a namespace does. It provides a way to group similar classes, and it can be used to avoid naming conflicts. Now, the parts of the method, their header and the body. The header is this. Static for right now, think of it as there's only one of them. Void means it doesn't return anything. Main is the name of it, and there are no parameters passed in. The body is what's within these set of curly braces. So our body is one line of code that writes on the screen, this is my first C# program. All right? White space is you hitting the space bar or the tab key or the enter key. Okay? It can make your program easier to read. We could have literally put all of this on one line, but it would have been darn hard to read then. C# has several keywords. They're in your book. We're going to go over them at the appropriate time. I already mentioned to you that the name of the method is main. Every application must have a main method. All right. The method returns nothing, so it has the word void right there. When we start to name our own things, those things that we name, the names of our own variables, which we'll get to in a bit, and the names of our own methods, those are known as identifiers. There are some rules regarding identifiers. Each must begin with either an underscore, an @, or a letter. They cannot begin with a number. After that underscore, @ or letter, you can have letters, digits, underscores, the @, but the key word is there, digits. You can't use reserved words, and don't start it with an underscore, and don't start it with an @. You're best off just using letters. If you do that, you're going to run into very few problems. Occasionally, you may have to put in a digit, but again, it can't be the first character. They talk here about a verbatim identifier. It says this feature allows you to use code written in other languages that do not have the same set of keywords. We're not going to worry about that, at least for now. There are some identifiers in the C# language that have special meaning, but they're not keywords, and there's some examples. You'll know once you start creating things, what's a keyword and what's not. We'll get into that as we go on, all right? Okay, they talk about a shell here. Let's not. This just says that every program that we create at the beginning is going to have this kind of a template. I'm not going to worry about it. All right. As C# programs, like any other programs, get more and more complex, they get longer. So you want to break them up sometimes not only using white space, but you may also want to break them up using program comments. All right? There's three kinds of comments. If you start a line, or if anywhere in a line you've got 2 forward slashes, then from the rest of the, right after those 2 forward slashes to the end of that line, so to the right, is all a comment. In other words, it's ignored by the system. If I want to comment out 3 lines in a row, I can either put / / at the beginning of each line, or by the first line I can put /*, and by the last line I could put //. There's also an extra or another type of special comments that are called XML documentation format comments, so we'll talk about it at a later time. All right, so here's an example of comments with a //. So these are called line comments. These are called block level comments because they at least can be over several lines. So here we've got another program, and you'll notice since we're using write line, it means write this, then hit the enter key, write this, then hit the enter key, write this, then hit the enter key. So you see line 1, line 2, line 3, which is line 1 and line 2 and line 3. Those are, each one of those are the arguments to the write line function. Okay? Now notice again, we have system.console.writeLine 3 times. We have no using statement up there. Once we put the using statement up there, and I guess we can just say using system, not using system.console. All right? Oh, I'm sorry. If we say using system, then we have to say console.writeLine. So it's a little better. And if we say using, we need the word static system.console, now we can just say writeLine. If this doesn't make a lot of sense, it's to be expected. We're just starting on our journey here. All right? When you go and compile a program, and we talked before about what compilation means, what happens is internally in the computer in C# is it compiles your source code, which you've written in the high-level C# programming language, into what's called IL, intermediate language. And actually, that's not true. It's called MISL, MSIL, MS for Microsoft, intermediate language. Then the C# JIT, or just-in-time compiler, will translate that code that you put into an intermediate language into something the computer can understand. You can write programs for C# in 2 basic ways. You can use the command line, and basically with a command line, it'll kind of look like this. All right, where you will write a program here, so it'll say something like, what is your name? And you'll put in there, Jeff. All right? And it'll come back and it'll say, like, your name is Jeff. Something like that. That is a command line type of program. We'll do that, but then we'll gravitate towards using the IDE, where we will have a graphical. All right, it'll allow us to create GUI or graphical user interface programs. All right. From the command prompt, though, as it says, don't worry about this because we will look at it at a later time. It really doesn't matter. Okay. When you do go and run a program, though, one of 3 things will happen. You'll receive an error, and maybe you noticed that with mine when I ran this. Those were operating system errors. It says you use the word what right there. I don't know what that means. You use the word your right there. I don't know what that means. If I even put in my age, it says it doesn't understand what that means. Those are all operating system commands. All right. I can receive other type of error messages. And you'll see that in C# if you're supposed to put a semicolon at the end of a line and you don't. Hopefully you don't get any error messages. All right, that means that the program at least compiled successfully. If it doesn't run successfully and you get an error, you want to look through and see, did you misspell something? Did you forget a semicolon, etc.? Did you make what's called a syntax error? All right, so syntax errors, as we mentioned, are errors in the rules of the language. Here we used right line, but that should be a capital W. That's a syntax error. If you receive no errors, then the program should run. Now that's all fine and dandy, but boy, it'd be a lot easier if we could do this and make it graphical so people could understand it easier. And that's why you typically will use something like Visual Studio. We're going to be using Visual Studio 2017. With Visual Studio, as it says, some of the code you need will already be created for you. You won't have a black background with white code. All right, you'll have a white background with black code, but keywords will be put in a certain color, comments will be put in a certain color, syntax errors, so if you forget a semicolon, the system will catch it for you right away and it'll put like squiggly lines where it finds the error. Okay, and there's other debugging tools available too. All right. This is, right here, this is kind of a mess when you look at this, but they're showing you when you go and you compile something using the Visual Studio Integrated Development Environment, or IDE, what are the advantages? We already mentioned. Some of the code's written for you. The code's displayed in different colors. It catches syntax errors. You can double click on an error to find what that error was, etc. Oh, I'm going backwards. There we go. So, one way to compile a program is to select Build. Another way is to do a Control-Shift-B. Another way is to select Debug from your menu bar. And yet another way that's not even mentioned on here is there'll be a green arrow up on the top of our screen and you can click that. We'll go through all these in class. If you get an error, the system will show you down here, if you're using Visual Studio, the Integrated Development Environment, this is your error output area, and it'll show you the error line number and what the error was. And if you double click on that, it'll take you right to where the error was. Here again, the W is in lowercase where it should have been in uppercase. If you receive no error messages, then the program was successful. All right? So, the bottom line is, would you rather write code that looks like this, or would you rather write code that looks like this that's going to be graphical in nature? You'll have a chance to do both in this class. The advantages of using the command line, your programs are going to be smaller, so they'll save disk space, but that's pretty much overridden by the fact that with the Visual Studio Integrated Development Environment, or IDE, there's what's called autocomplete. Words are displayed in different colors based on their context. It's typically easier to correct errors, and some of the code will be generated for you automatically. So, we've reached the end of Chapter 1. We learned that a computer program is a set of instructions that tell the computer what to do. We learned about the older type of programming, which was procedural, and the newer type, which is object-oriented. And object-oriented, again, is just an extension of procedural programming. We learned that objects are instances of classes, and classes are blueprints. We learned that C# is an object-oriented language. We learned what the system.console.writeLine method does. We learned a little bit about variables, which is a named memory location, and identifiers, which is how you name your own variables and your own methods, etc. We learned the 3 types of comments. Those were line comments, which were 2 forward slashes, which means the rest of the line on over to the right is a comment. We learned about a block level comment, which starts with a /* and ends with a / and can go over multiple lines. And we learned about an XML comment, which are within brackets, a less than and a greater than sign. We learned how you could use namespaces, so rather than having to write system.console.writeLine every time you're doing a write line, at the top of your code, before any actual code itself, we could put in using system.console, then we only have to write the word write line. That's a namespace example. And we learned that you can use either the Microsoft Visual Studio IDE or a text editor when you're writing this stuff. All right, so I'm going to copy this. Copy that slide, and I'm going to do a file open from right where I am. And I want to bring up Chapter 2, which is on using data. So I'm going to come up to here and I'm going to paste in, just put it here, I'll move it. So this will be Chapter 2, and it is entitled Using Data. About the same exact number of slides that we just had, so the next presentation will take around the same amount of time. I'll be back with that second chapter shortly.